Lesson 4.7, going to talk a little bit about coordinate proof today. Here we go. All right, we've used coordinate geometry to find midpoints, slopes, and distances. A coordinate proof is a style of proof that uses coordinate geometry in algebra. So we're not really going to use two-column proofs when you're doing a coordinate proof. It's more so using the coordinate plane and those formulas to kind of go through it. All right, so strategies for positioning figures in the coordinate plane. Use the origin to help you out. Try to keep the figure in quadrant 1 so you can keep everything positive. Use the origin at 0, 0. And use the axes to help you out as well. So position a square with side length 6 meters in the coordinate plane. Well, if you're going to do that, you could go 6, use 0, 0 to help you out, and then make your life as easy as you can. So there would be our 6 side length 6 square in the coordinate plane, and then you could put your lines on there and go with it. Position a right triangle in the coordinate plane, leg lengths of 2 and 4. Hint, use the origin as a vertex. So that would be your right angle where the x and y axes come together. So then you could have 4 and 2. Now, could you go the other way with it? Of course, either way would work. Okay, use that axes to help you out. Once it's placed in the coordinate plane, you can use slope, distance, and midpoint to prove statements about the figure. So write a coordinate proof. Given that rectangle, prove that the diagonals bisect each other. Well, we'd want to go back here. We would want to graph that first. So we have 0, 0, 4, 0, 4, 10, and 0, 10. So A, B, C, D, there's your rectangle. To prove the diagonals bisect each other, so we got A, B, C, D, we would want to show something bisects, you would want to find the midpoints of those and show that they are the same. So if we want to find the midpoint, you can use your coordinate geometry formulas. AC would be 0 plus 4 is 4, divided by 2 is 2. 0 plus 10 is 10, divided by 2 is 5. So the AC midpoint is 2, 5. And then the other diagonal would be BD. So we go 4 plus 0 is 4, divided by 2 is 2. And 0 plus 10 is 10, divided by 2 is 5. So 2, 5, 2, 5. If you can show the midpoints are equal, you can show that the diagonals bisect each other, which is exactly what we did. All right. A coordinate proof can also be used to prove that a certain relationship is always true. You can prove that is true for all right triangles without knowing the side lengths. To do this, assign variables as the coordinates of the vertices. Okay, so if you're going to do that, it doesn't really matter how long you make things. You still want to use 0, 0 to help you out, but position each figure in the coordinate plane, a rectangle with width m. So I would go m, and then, you can make your rectangle, and then that would be 2m. So if you were going to write down those points of the vertices, you'd have 0, 0, 0m, 2m, m, and 2m, 0. When you're using those variables, it doesn't really matter how long you make things, as long as you make them consistent. Right triangle with S and T. So once again, you're going to want to use the 0, 0 and the x-axis. So you could say S and T. So your coordinates would be 0, 0, S, 0, and 0, T for your right triangle. All right. All right. Do not use both axes when positioning a figure unless you know it has a right angle. Let's try another one here. Square of 4p. Well, we know a square has a right angle there. So we could go, all the side lengths are 4p. So we could go 0, 0, 4p, 0, 4p, 4p, And 0, 4p would be those 4 coordinates of the vertices. Okay. All right. If coordinate proof requires calculations with fractions, choose coordinates that make it simpler. Use multiples of 2 when you're using midpoint. That way, when you divide by 2, it comes out with nice, neat numbers for you. All right. Use the information in example 4 to write a coordinate proof showing that the area of ADB is 1/2 the area of ABC. So we've got those coordinates, and there's the graph. So we're trying to show that, hold on a sec. ADB is half ABC. All right. So we want to show that ADB is half the whole big triangle ABC. All right. Well, let's find ABC area first. Area of a triangle. Half times base. Well, how far is it from here to here? Well, that would be 2n times height, there to there. Well, that would be 2j. Well, the 2's cancel, and that gives you 2jn for ABC. All right, on the previous slide, it told us that D was the midpoint here of AC. So 0 plus 2n divided by 2 is n. 2j plus 0 divided by 2 is j. So D is nj. Okay, so now we want to find the area of this. Well, it's not a right triangle, but this would be the height, and this would be the base. So to find the area of ABD, we take half times the base, which would be 2j, times the height. Well, how far would it be there to there? It would be n. The 2's cancel out, and it leaves you with j times n. So that's jn. ABC is 2jn. Just used a coordinate proof to show that ABC was double ABD, or ABD is half ABC. All right, so when you're doing those coordinate proofs, you're going to use slope, distance, and midpoint. Don't have to do the 2-column type deal when you're doing those proofs. All right, that's a wrap for 4-7.